The James Webb Space Telescope has only been operating for 2 years and has already opened up the cosmos to humanity in ways we could only imagine before. From discovering the most distant galaxies ever observed, to protoplanetary disks in the Orion Nebula. It's been able to look around our own solar system in unprecedented detail and other solar systems to see the composition of atmospheres around worlds light years away. And that's just in its first 2 cycles. Now several teams working with JWST in its 3rd year of operation called Cycle 3 will be taking it to the next level. In this round, they aren't just looking for exoplanets, they'll also be searching for exomoons, moons around planets circling other stars. The fact that we can see exomoons potentially from near Earth is incredible. Of the 253 projects that were selected for Cycle 3, only 2 are searching for exomoons. The first was proposed by Dr. David Kipping of Columbia University, and this guy is dedicated. Dr. Kipling has submitted several proposals for both of the previous cycles, but they've all been rejected. So when he submitted this one, he was hopeful but not overly optimistic. He and his team will be studying the Jupiter-sized planet Kepler-167, which is about 1,100 light years away. If he's right, they should be able to spot a moon or moons the size of Ganymede or Callisto, which is a little larger than our moon. The second of these amazing projects to search for exomoons was submitted by Emily Pass of the Center of Astrophysics at Harvard and the Smithsonian. Her and her team will be looking for a planet that is much, much closer. Their planet, TOI 700, is an Earth-sized planet around a red dwarf star around 100 light years away. They have the goal of finding a planet-moon system that is very close to our configuration, which would be incredible if they accomplished it, since the Earth and Moon seem to be an incredibly unlikely arrangement. Looking closer to home, Mike Brown of the California Institute of Technology will be taking a close look at the plumes coming out of Enceladus. He'll be trying to figure out if the plumes are coming from a sea deep beneath the ice that covers Enceladus or starting much closer to the surface. From within the ice sheet itself, he'll primarily be looking to see if the plumes are constant, or if they pulse on and off again. If he sees that they're constant, he'll know that they're coming from the ice and not a subsurface ocean. If they were coming from the ocean under the ice, the release of water would be timed to the tidal forces in its orbit around Jupiter. As Brown put it, we need to know the answer to this question before we send anything. Finally, moving now into the far reaches of the universe, Jehan Kartaltepe of Rochester Institute of Technology will lead a team that will look to massively increase the number of red-shifted galaxies that we know about. Previously, finding these galaxies was a long 2-part process that required finding them, then a follow-up study to characterize them. The net result was that we didn't get a lot of data very quickly, and the more data we have, the better we can model these mysterious objects that, until recently, we didn't think should exist in the first billion years where they were being found. They'll be using a technique called slitless spectroscopy, where they'll allow the telescope to get the spectra of everything in the image all at once. Doing this should give good data on about 3,000 galaxies from the first 750 million years of cosmic history. This is just a handful of the projects that JWST will be looking at over the next 12 months. Make sure to like and subscribe to the Space Missions Report to get the results of these projects and more. Also, comment below if there's a specific JWST target that you're excited about. Till next time, keep looking up.